I've remounted this electrolyzer that I've been showing in the last few videos, and also done a little bit of adjustment on the resonant portion of it, which is quite dramatic in what happened. And what it does, by readjusting that particular section of the circuit, I have eliminated one of the 3 electrodes and still maintain the same production of gas with the same, if not a little less, energy input. Here again you can see that the negative rail is hooked to the SEC exciter. A couple of comments on this exciter. If someone were to try to replicate this on their own, the exciter does not include the 10 microfarad filter capacitor on the power rail, and the protection diode that normally is on the rail is disabled and is pulled out. If that diode's left in, this will not function properly. Okay, so you take the 10 microfarad off the board if you have one, and you also can pull off the protection diode. And the negative is the only lead that feeds into the exciter. Also, I have reduced the size of the heatsink here, mainly because it's not necessary to have that large one on that I've had in the first few videos. The transistor runs probably around 40 degrees C, and this is not an MPS A06. This is a different transistor that I'm using in this particular circuit, and it's a PN, P as in Paul, N as in Nancy, 100. And so here's the circuit. This little board back here has all the diode arrangement on it, and it was a lot easier than having everything hanging in the air. So there's nothing really mysterious about that except the diodes are on it. And now we're down to 2 coils, the external large coil and the internal smaller coil. The third electrode that was in the center of the small coil is now removed. Let me go ahead and apply power here, get this thing started up, and we're looking at, let's see, I got to do some adjusting on this. There we go. Okay, I had to get it into resonance. Let me go ahead and slip that black paper in behind it again, because it makes it a whole lot easier to see that production. And this was a fresh beaker of water, so it'll take a couple of minutes to ramp up to full speed. But you can see that we still basically have that exact same phenomenon in the center. You can see all of that gas rolling off of that small coil. And the gas production is the full length, as you can see. If you look down here at the bottom, see the production as we move on up through it. And you don't see a proportionate amount of gas coming off of the large coil. In fact, not that much at all. And this is a phenomenon that has existed in a lot of the resonant-driven circuits, in that it appears that we have a disproportionality in what's being actually produced here. You can see we're starting to cloud up now quite readily, and you can see how it's coming out of the top. Now after this runs for a few minutes, you'll actually see a gas vapor start rolling off of the top of the water, and that can be ignited. It'll just pop, or you'll hear little firecracker sounds as it rolls off and you ignite it. And what will also happen after this runs for about 30 or 40 minutes now, the gas that's in the water, the bubbles are having a real hard time, and I'll explain that in another video, escaping out of the water. And that's due to a polarity and an attraction to the water molecules itself. But anyway, as this milkiness will build up here, over a period of time they will join and form larger bubbles within the top surface. But yet the attraction until they get so large is great enough in the water molecule that they'll still stay within the top layer of the water. This is a very different phenomenon than ordinary water electrolysis. Normally you would have trouble in the bubbles releasing from the electrode, but in this case the bubbles release fine, but they have trouble escaping from the water. So anyway, I just thought I'd go ahead and put this up because this is going to make it a lot simpler now for people to actually replicate this and understand the theory behind it. The geometry is important, the size of both coils, as well as the resonance that's derived and how it's done here with the two L3s. And remember, there's no negative terminal feeding into this circuit at all. As I turn this around, what you're going to see is this is the positive terminal here. It comes in, it's going up to this terminal block, and it's going through a 1N4148 into the larger coil. That's the positive. And of course we only have the inner coil, the small one, which is actually coming back through here, going down here through a diode, going up through this L3 back to a capacitor fed portion of the SEC exciter. So everything you see here is strictly AC. It is not a DC connection. It's all AC. And you're going to ask, well, how is that exciter running? Well, that's part of the actual circuit that I'm going to have available in the evaluation units on exactly how this thing is running in an AC mode.